Okay, everyone. Let's start the next talk in that session by Mike Krus of KDAB fame about getting Qt on iOS up and running. Welcome.
Right. Good morning. Thanks for coming. My name is Mike Krus. I work for KDAB, based in the UK, and I'm going to talk to you about Qt for iOS. So this is an introductory talk about how you get up and running to get a Qt application running on iOS. So I'm going to talk briefly about the software environment and then dive into the toolkits and all the machinery you need to get installed in order to develop Qt applications. So both the native tools and then Qt itself. And then we'll look at how you build up a project from nothing and how you set up things, how you need to define some things that are particular to iOS compared to other platforms. We'll then discuss briefly QML for iOS and how you get user interface up and what some of the challenges are for mobile devices in general and iOS in particular. And then we'll look at all the things that are not covered by Qt and how you can potentially access the native toolkits directly from your applications. And then at the end we'll discuss, show a brief example of how you can put something together just in a few hours. Hardware platform, just in case you haven't heard about iOS and the iPhone before, or been trying to ignore it. iPhone, Qt supports anything from the iPhone 4 and upwards, mostly because it requires iOS 5.3 minimum, but otherwise it will run on iPhone and iPad just fine. All those devices run ARM chips, initially designed by Samsung, but now Apple does all its own design of the chips that are on board. The graphics are usually pretty good for mobile platforms. It's all PowerVR, so it does OpenGL, ES 2 and 3 very nicely. It usually comes with a full complement of sensors. The phone in particular will have the GPS, magnetometer, or the tilt sensor. Some of the iPads tend to be missing some of those. The iPhone 6 introduced the pressure sensors too. Screen resolution is an interesting one, and we'll talk about that a bit later on. If you've been on mobile platforms before, especially on Android, you'll know there's a wide variety of different form factors and pixel densities and all of that. It's not as wide on iOS, but there's two big categories of screen aspect ratios you need to deal with, so iPad and iPhone, and based on that there's a range of pixel densities that you need to handle and have assets ready for, and we'll talk a bit about that later on. So yeah, quite a modern and fast CPU and GPU. It does calculations quite fast, it does rendering very fast. In terms of what goes around it, it's back to the 90s really, or say 80s here. They have 512 megabytes of memory, 2 gigabytes on the very latest models, but it's something you need to be prepared to work with in terms of constraints. You can't load up as much things as you would on a desktop computer. Software-wise, here I'm going to address iOS 8 and Qt 5.5. So the minimum that you can run a Qt application on, I think, is now 5.3, but you need at least Xcode 6 and iOS 8 in order to actually develop the application. You can just say I'm enabling it on older platforms. Internally, the operating system that runs on iOS has lots of common things of what comes with the OS X. So it's a Mac microkernel, BSD libraries are all there, and available with some restrictions that we'll talk about later on. It has a lot of the Apple system libraries to do audio, animation, location, all the video, the multimedia things, and they share a lot in common with the macOS versions, and some of the Qt, the native implementation of some of the modules is actually the same on macOS than it is on iOS. The toolkit that used if you're going to do native application on iOS is called QtWS15. It's all Objective-C, and we will show some Objective-C a bit later on, so don't all run away. It's all natively designed to work with touch, so it's a toolkit that's completely different from the macOS application toolkits. The main one is UIKit, that has all the standard widgets to do buttons and tabbed controls and all that kind of thing. And it has many other ones, MapKit to do maps and a whole bunch of there's a huge set of them. Much larger than what Qt can possibly cover, so that's why at the end we're going to talk how to integrate with these. In terms of user interface idioms, and I'm talking about these because it's quite important when you're going to put an application up on the store that it behaves in a way that iOS users are going to expect. So, it's great to experiment with different forms of user interaction, but you also want to make sure that the users that are normal iOS users can be familiar with your user interaction paradigms. So UIKit will have sort of a page-based user interface where you swipe from one page to the other, or tabbed versions of the user interface. One popular one also is the master details. You have a list of items and you select one and you would have the details of that one item exposed on another screen or on the side if it's a tablet interface. So it's important to try and build those kinds of paradigms when you use Qt, just for familiarity. It supports also all these navigation, so popping a new view or pushing a new view into stack and popping back to the previous, the normal kind of thing you would find on mobile devices. It tends to not do modal presentations too much, but there are some, and there's a limited set of modal dialogues that can be used. And we'll go through some of those. One thing that it does a lot is animation and transitions from one set of one view to the next. And it does that with a very powerful animation engine. So again, when you replicate that in your application using Qt, it's quite important to think about that and try and introduce some kind of animation too. Requirements in order to develop an iOS application. You must have a Mac. It's a great thing to get to your boss and say, yes, I do need a shiny MacBook. You don't need a very powerful one. A Mac Mini or even a simple MacBook, basic laptop is fine, depending on your application, of course, but in general, you don't need something too powerful. You can't use a virtual machine unless that machine is running on a Mac. So you still need a Mac even if you're going to use a virtual machine. It's quite useful to set up an environment. So all of these are not technical restrictions, they're legal restrictions due to Apple's terms and conditions as to what you can use macOS on. You'll need an Apple ID and register with Apple. That's just providing an email address. You don't have to pay straight away. But in order to publish your application to the store, then you do need to get a developer subscription from Apple and pay them, I think it's $99 a year. But that's $99 no matter what the size of your team is. So for a big company, it's still $99. There's no limit to the size of your team. iOS 9, which was released a couple of weeks ago with Xcode 7, introduces personal teams. And then what that lets you do is that previously you would need to have a developer subscription to run your application on your own device. So you had already paid for your device and got a Mac, and you still need to pay Apple again to run the application on your own device. With a personal team, it lifts that limit. And final piece of the puzzle, you need Xcode. Even though you're going to develop most of your application from Qt Creator, you do need to have Xcode up and running and make sure it works for you before you can actually start using Qt, because Qt and QMake internally will use Xcode to do the actual build. Now, don't be afraid of Xcode. It's actually a pretty decent IDE. If you're doing pure native things, it has a very nice graphical layout tool. The concepts of the language are very well integrated in all the different UI elements, and it's really nice to work with. If you don't do native stuff, you still need to go and use it in order to set up all your user developer account. I'm not going to go into the details of that today, but when you register, you need something called, all the applications that run on the device are code signed, so you need to have a key to do that. And then they have what's called provisioning profiles, which controls where the application is allowed to run and certain of its capabilities. All of that is controlled from within Xcode, or most of it. It used to be a nightmare of having to jump through a couple of Apple websites, but now most of it is driven from Xcode. So you want to go in there and at least look at its preferences and enter your developer details in there so it can do all the stuff it needs to do to handle the code signing. It also has extensive documentation built in to it, and you need it in order to publish your application from the store. So a creator is not able to do this last bit of you're happy with your application, you're ready to publish it to the store, you need to use Xcode for that. And it actually has a very good debugger. It's pretty useless to debug QML, but if you're debugging your C++, Xcode is actually quite a good option. It doesn't know about Qt data structures, so you can't look inside a QString, for example. Before the rest of your native code, if you have some C++ shared business logic, things like that, it's actually quite good, and it's got an extensive set of profiling tools that you can use if your application is slow or is leaking memory or things like that. It is pretty good. It also comes with a simulator. So it is not an emulator. So when you compile your application for the simulator, what you are building is actually not an ARM binary, but it's an x86 or an x64 binary, which means it has very different behavior from when it runs on your device. It starts up very quick, similar on the device, but if you use the Android emulator, you'll know that it takes forever to start up. This is really, really quick because it doesn't need to do any emulation. It links against x86 builds of the iOS APIs, which are mostly complete, but not all of them. So some of the things like sensors obviously are not exposed, and things like location will be simulated. It won't provide access to the camera and things like that, so you can't test all the devices. The runtime environment is also very different because it has access to all the memory that's on your computer, not 512 megabytes. So you're happy, you allocate lots of memory, and then you run it on a device and it crashes at startup because they don't think about that. The performance is quite different. Obviously, it has lots more access to all the cores and the OpenGL performance. So it's basically simulating OpenGL ES over a full OpenGL stack. One of the things also it doesn't do when you're running on the simulator is code signing. That's only required to run on the device, but sometimes some applications trip over at code signing time. So it's really important to run on real hardware and plug in your phone and run the application on it. I mentioned it previously, just before, the applications must be code signed, so that's all handled by Xcode. When you're running from, when you create your project in Creator, usually the first time you run it for a new application and try and run it from creator to deploy on your device, which will normally do quite happily. The very first time it fails because it needs to get these code signing entitlement. So the very first time you need to go to Xcode and run your application from Xcode so it can talk to the Apple servers to get all this code signing sorted out. After it's fine to just run it from creator. There's also this notion of provisionings profile that I talked about previously, just briefly, and that links. There's two types of provisioning well, several types of provisioning profiles. Won't get to the details of that today, but it controls who can use your application, and some of the more advanced features like access to iCloud or the health APIs or the push notifications, they need to have provisioning profiles, and that you do that from Xcode. Again, you only need to do it once for your application, then it gets remembered. So yeah, don't be afraid of Xcode. You're going to have to use it, so it's a good thing to learn it. Some restrictions for applications when they're run on the device. Yes? Well, it encodes some capabilities of your file, of your application. So it used to be a little file that you need to bundle with your application. Now it's all handled internally by Xcode, so it's mostly hidden. But it's basically a bunch of switches for these capabilities, for these libraries like iCloud and push notifications. I'll show you later on in Xcode how you can control them. So sandboxing. Apple, iOS, and actually also macOS has sandboxing. That means an application at runtime is restricted as to what it can do. In particular, in terms of access to the file system, it only has access to its own file systems. You can't access files that are elsewhere on the system or part of other applications. And it has restrictions in terms of what you can do also in terms of shared memory or access to or ability to create daemons and that kind of thing. So it's quite restrictive. One thing to do, that first point up there, is not really about sandboxing, but even within the confines of your own set of files for your application, and we'll see how that's laid out later on. You typically do not show files to the users in an iOS application. It's very rare to open up a file browser. Other restrictions in your applications, the native, so Objective-C supports quite a powerful introspection mechanism to find out the methods that are available on certain classes and things that happen like that. And it's quite tempting to use that to poke inside the system libraries and do special calls. So that's called accessing private APIs. Don't do that. Your application will be rejected once it's submitted for review. You can't download code, and it doesn't authorize just-in-time compilers. So in particular, that has an impact on QML. Because all the JavaScript is interpreted rather than just-in-time compiled. So it's a bit slower than on other platforms. A lot of work has gone into 5.5 to mitigate that constraint, but it's still a difference in performance. So again, test it on your device and see how your application performs. Yeah, QML file and JavaScript, things like that are fine, but because they are interpreted, they're not actually binary code. One thing to get around some of those restrictions introduced in iOS 8 is this notion of application groups. And if you build several applications for the device, you can have them share a common set of files. So that's one way of sharing files between your own applications, but it doesn't let other applications access your own files. Right, another piece of the puzzle when you're programming iOS applications is iTunes Connect. So the first one was the Apple developer website, where you need to register first. Then there's Xcode that you're going to use on and on, but you do need to, on and off, sorry, but you need to use it. The third bit is iTunes Connect. That's a website, itunesconnect.apple.com, and that's where you need to register your application before you can publish it. So it's the backend to the App Store, really. So that's where you register your application. You put all the marketing blurb, the screenshots, and all of that. And you typically don't need to do that until quite late into your development process, but it doesn't hurt to do it early. One of the advantages of doing early is reserving your name of the application, because that has to be unique. But if somebody steps in and uses the name you were planning to use the whole time, then you've lost it. So that's also used to manage all your versions, your different builds and things like that. And I'm not going to go through the details of that today, but it also manages something called test flight, which is a way of distributing your application for testing. So it has a whole mechanism of you uploading a build, having user register or invite user to have access to that specific build and let them directly download on your device. Because normally code signing would stop you from letting you send your build to just anybody. You normally can only distribute through the App Store. So just a very brief overview of the tool set and the steps you go through to go from starting to develop to an actual release of your application. So you need to enroll with the program, and that's only needed really if you need to pay only if you're going to publish to the store. Then you develop, you create an app record, so that's in iTunes Connect. You upload, and then you go either to testing or you submit your application to review. So the App Store has a review process. So your application gets used by an actual person who goes and uses tools to go and check that it's not doing something it's not allowed to do. It checks that it's actually working, that it's not crashing all the time, that it's actually doing something useful, it's not just a splash screen. So there's an actual review, and there's a whole bunch of guidelines you need to follow about that, and I'm not going to go into too much details about what they are. Potentially your application will be rejected and you will have to fix things, including things that might have been present in the last 5 releases of your application, but suddenly Apple has decided that they're not good and you need to change them. Apple, it's their store, you need to follow their rules about what goes on their store. Right. So that's what general, sort of not necessarily related to Qt rules. So how do you do Qt on iOS? I think the first version was introduced in 5.2 as a pre-release. 5.3 was better, was still not very nice experience. As a 5.4, it's much easier to work with, and it's much better integrated into Qt Creator in particular. And 5.5 most recently has completed a lot of the holes there were in the coverage of the various Qt modules. One thing to note is that it requires a static build, mostly because of rules of the platform. iOS required static, but didn't allow linking to dynamic linking to libraries, until iOS 8. So iOS 8 has lifted that restriction. You're now allowed to do it. And it was a purely rule, the system did support dynamic linking, but it was just forbidden by Apple. Now you can link to your dynamic libraries. Qt itself is still built statically, and by default, when you build your own application, it will be statically linked to Qt. There's no easy way of getting Qt to build dynamically, so we're working on a patch for that to make it easier. It's not a huge advantage actually, because of the sandboxing restrictions don't let you link to anything that's in another application. So you're not going to save any space by only having one copy of Qt. You're still going to have to bundle Qt with every single of your application. But it might be useful for some applications like things like do extensions that let you embed your application within another one. In that case, it's quite useful to be able to have the code that's in common into dynamically linked libraries. And we'll touch a little bit about that at the end. Qt, so all the non-GUI bits are essentially BSD, Mac backend, so everything works fine. Things like shared memory actually work fine, except until you try and use them, because the sandbox will block them. The QPA does the rendering using a UI window, and the backend for that is all OpenGL. iOS builds its entire user interface and renders it using OpenGL, very much like QML. It's possible to use widgets, but I would not recommend it. I'll show you why in a bit. So Qt Quick UI again integrates completely with the QPA and the underlying OpenGL rendering engine. Of course, you'd have none of the things I talked about earlier, which is the native way of doing user interface in terms of support for navigation or tabbed controllers and things like that. So you have to build all of that on your own. So quick tour of Creator. I might skip it because I'll have an example later on. QMake. So how do you control things that go in your project? So I will actually show you very quickly. If I hide this. Where did it go? Sorry, I need to find it on the disk again. Try and find a build. I guess you can just barely read this. So this is a build folder from an iOS application. So the result of running QMake. So it uses make to do the build, but you'll notice here at the bottom it's created an Xcode project, which is down here. So QMake, when it runs, will create an Xcode project because it actually needs to run that in order to do the code signing bit at the end. It also generates this info.plist file, which is quite important, and we'll discuss it a bit right after this. And then when you do a debug build, it'll put the executable, the application bundle, and it'll go to some details of what's inside of that. So yeah, make files, an Xcode project, an info.plist file, all your QML files by default in the project that Qt generates are stored in resources. It's probably the way to go. It has a main.cpp, which is typically trivial. It creates GUI applications and loads some QML. We'll talk about the rest at the end. One of the things it does do for you, which is really useful, is these last two files, which QMake will generate for you, and these are the static macros, or the macros you need to use in order to load your plugins when you're doing a static build. So when you do a normal non-dynamic linking build, those will be found at runtime. When you do a static build, you need to tell Qt which libraries to link against and which headers to which symbols to import from those libraries. So it generates those two, QMake generates those two CPP files that you need to build and link inside your application along with all the Qt libraries. It's one of the bigger advantages of using QMake is building these things dynamically. So that basically listing all the modules that you are importing in your project and all the QML libraries that you import. The result of an application is called an application bundle. A bundle is basically just a directory that by default the Finder will just hide from you and make you appear as a single file. But if we quickly look inside the bundle here, show package contents. So that's an iOS application. So it's obviously hasn't been copied onto the device, but you'll see this is the actual executable qt.conf file and some other files. But essentially, this is a folder that gets copied onto deployed onto your device. When that is done, when it runs, this operating system would actually make sure that it has a certain number of folders inside of that. So you have a document folder, which is where you should store the files that your application produces. Those get automatically backed up to iCloud and restored if you restore your device. And it has a bunch of other folders. One of the most interesting ones is library caches, which is a good place to store your cache files. So if you're downloading images from the web, store them in there. Be prepared for them to not being there the next time your application runs, because if the operating system detects it's running low on disk space and needs to make disk space available, it will go through all the installs application and clear the contents of that folder. So it's a cache content that you need to be prepared to recreate the next time your application starts. So we'll never delete it while your application is running, but be prepared for the content to disappear. It also includes this info.plist file. So that's an XML file that contains information about, it's metadata about your application. So what the developer, the name of the developer was, some supported platforms, so you can restrict it to only run on phones, for example, versus tablets. Restrict some architectures to maybe only do 64-bit, not support older platforms. Copyright messages, you can change the name that appears underneath the icon when the application is installed on your device, because if your application has a long name, you need to have a shorter string underneath that. And some unique information about your application, so the unique identifier that you register with the dev site, and things like version number and build numbers. And also within your application, you can bundle any kind of files that you want. So typically, if you don't want to put things in Qt resources, if you have big images or something like that, it might not be a good idea to put them in your resources. You can bundle them just as files that get copied into that folder when the application is installed. So it's a good way of shipping extra pieces of data with your application. Now, how do you configure that from QMake? QMake has these conditional variables. So if you if you test for Mac, that means you're building either OS X or iOS. And if you need to target specific ones, you have these other variables. And then there's a whole bunch of variables that you can define in order to restrict the deployment targets. So that's the minimum version of iOS that you want your application to require when it gets installed. So here, if I say 8 and the user has 7, then it will say I can't install the application. Target device family is how you restrict an application to run on either iPhone or tablet. So 2 is tablets, iPads, and 1 is phones. And you can do 1, 2 to support both, which is the default. And you can restrict architectures. Now, if this info.plist file, if you don't provide one, QMake will generate one for you. Because it has a lot of information that's quite useful and that you want to be able to control, like your developer name or your application name and things like that, it's a good idea to build your own plist file and tell QMake to use it. So that's what we're doing here with this variable at the bottom, QMake info plist. That tells it QMake which plist file to use. In this particular case, I'm using a QMake trick to substitute variables in my plist file for their values when QMake runs. So it's quite a useful trick to set a version number and a build number and then use this substitute construct from QMake to replace the values at runtime. Just a useful trick. So a typical plist file, so as I said, it's an XML, has a bundle identifier, which you need to register with the dev site. The bundle display name is this string that appears underneath the icon. The short version number and the bundle version number. So the bundle version number is actually the build number, and that's the version number. So you can upload several builds to iTunes Connect. Have them tested, but at the end you're going to release a specific one. So they all have the same version number, but the build number needs to increment every time. You need to say you require an iPhone. Oops, sorry. You require iPhone. You can also restrict the orientations that you support if you don't want to do too much work on resizing. Another useful key here at the bottom is UI file sharing enable, and that makes sure that if the phone is plugged into the computer and you start up iTunes, the application will appear with iTunes and you can see the contents of that documents folder from iTunes. So it's a good way of extracting or importing files into your application. So if your application needs other files, it's one way of doing it. Very briefly, how you customize the icons and the splash screens. So we saw there was a way of copying files into the bundle, and that's using these QMake bundle data, which you provide a list of these compound QMake variables. So if you do a meta.file, let's say I'm going to copy all the files that are in my source folder. And if you don't provide a .path extension, it's going to copy them at the root of your bundle. You can also provide a path inside your bundle, so that's one way of populating your documents folder, for example, or of putting files in your library folder. So you use this macro to copy all the files into your bundle, and then if you're very carefully build these file names and build them as PNGs, and you're very careful about the size of them. That's how one way of providing the icons. The list of the exact file names and what size they should be is in the Apple developer documentation. The other way of doing that is using what's called asset bundles. So it's these .xc assets, files/bundles, so they're effectively folders. And now these are edited by Xcode. So you run QMake, it's generated an Xcode project, you go into your Xcode project settings, you generate a new bundle, you fill in your icons, and then this bundle, you need to copy it back to your project because you're working on a copy that was just generated by QMake. So you want to make sure you copy it back to your project and then have, using these two lines at the top, have your copy used as the master version later on, and we'll show quickly how you do that at the end. Right, so that's basic setup of your projects and how you define your application icons, splash screens, your version numbers, and things like that, straight from QMake. So normally that's some things that you would set up from Xcode, but because your Xcode project is generated by QMake, you would have to do that every time you did a clean build, which is obviously not something you want to do. User interface-wise, widgets work. They look like this. If you can see, I don't know if I can make it bigger. You can't really ship that. You can't really ship a mobile application that has a file menu. The combo boxes, they work. They expand like regular combo boxes, but if they expand down the bottom of the screen, then they won't scroll up or anything like that. These spin boxes are completely unusable on the mobile devices. That's 5 pixels wide. Yeah, don't do it. QML, I think, is the answer for that. So the whole UI is rendered in OpenGL, the same as on the desktop. I won't teach you too much about QML. Some of the pieces for mobile platform that are quite useful is come from Qt So the quick controls, though, have not been themed to look like native controls. So if you use quick controls in terms of buttons and sliders and things like that, they look like this. So they're not particularly useful. So you can build your own themes, customize their appearance using the theming engine that comes with Qquick controls, but it can be a bit of a pain. Layouts, of course, are quite useful in Qquick controls. One of the interesting ones that talked about combo boxes is that if you use one of those, it would actually do a native spin dial at the bottom of the screen that you've probably seen in a lot of iOS application. It has this spin controller, so it has a special case code for iOS for that. The stack view is quite nice because it knows about pushing and popping views onto and off the stack, and it does this slide in and slide out animation. So it might be a useful one to use. File dialog, I mentioned, don't use it to browse for files because it does look like a desktop file dialog, except it has one special case if you browse for pictures. So it has this file dialog.shortcut pictures. In this case, it will use a native picture browser accessing the pictures that are on your device. So it's the one case where you're probably going to use dialogues. All the other ones, you can't use them. The color picker, even the message box is unusable. It looks like a desktop one. Text input behaves slightly differently. 5.5 is actually quite nice in terms of how it looks. It does have a mechanism for selecting that's close to the original one, but it doesn't have things like if you long press on text in a text edit field on iOS, it'll pop up a little loop to help you control where you move your cursor. That Qt doesn't do that. Other thing is that keyboard avoidance can be a real pain. So if your control is underneath the area, it gets a focus, so the iOS will show the keyboard, and if that control is underneath where the keyboard appears, then the default behavior for the Qt application is to scroll your entire application up high enough so that control is above the keyboard. Might be good enough. Sometimes you really want to have a different kind of animation, so you need to sometimes fight Qt and to stop it doing that so that you get notified of the focus change, move your control yourself somewhere else, doing some nice animation, and then have the keyboard show. So there's methods that let you control that to some extent, but you do need to fight Qt a little bit. One thing about screen resolutions. Most of the devices, so everything since the iPhone 4S, the iPad 3 and the iPad mini 2, I think, is in what's called Retina display. So it's high pixel density. The way the iOS native toolkits handle that is that they report screen sizes in points. So the original iOS was 320 points or 320 pixels wide. When they doubled that for the Retina display, 640, so you have 640 pixels, but the application or the system report specifies dimensions in points, and on Retina display, a point is 2 pixels, which means when you go from a 4 to a 4S, all your applications just work. They continue to work fine because all the sizes were scaled for you by their operating system. Great. The only thing that was not great is images, because your images was designed for, say, 100 pixels, but suddenly they had to actually cover 200 pixels. So the operating system would scale your images, and they would look all blurry. They don't look nice at all. So again, the trick that iOS used then is these @to resources. So when you reference an image and you stick it, so say your image your image here is designed to be 200 by 200. If that's actual pixels, then it needs a 200 by 200 pixels. If you're on a Retina display, it actually needs a 400 by 400 image to fill that area and be pixel perfect, because you do not want to scale images. So in order to support that and support the both cases, iOS introduced these @to notification, this @to string. So if you reference to an image as foo.png on a Retina display, it will look for a foo @to.png image, and it will use that instead. And that image needs to be twice the size of the regular one. Now, QML has adopted that too. Automatically, all your sizes are defined in points, so they will behave exactly the same on a non-Retina display as they do on a Retina display. And if you provide an image using your sources like that, QML internally will first look for an @to image if it finds it. Otherwise, it will use the regular one and scale it up, and kittens will die. Do not scale up images. iOS, the 6 Plus introduced an @3, but that's not supported by QML. But do embrace this. Do not try and scale things, especially if you have images. It looks awful. Yeah, build your, if you use QML, build your own libraries of items and build up on that. I'll go through an example of that, so I'm going to skip it now. Right. Qt modules, what's covered, what's not. The coverage from 5.5 is actually pretty good. It supports nearly all the sensors, not the pressure sensor. It has somewhat weird omissions in some sensors. The magnetometer, for example, only reports true north. It doesn't report magnetic north. If it's important for your application, you need to work around that. The positioning thing is fine. The new map module in 5.5 is also fully supported. It also has the new in-app purchase, which lets you do that transparently between iOS and Android. Qt3D, the version that's out in 5.5 is broken for iOS, but the 5.6 one is fixed. Sometimes it's not enough, though. There's a lot of things that are not covered by Qt. If you want to do background long-running applications, if you want to use the sharing frameworks to share some image through Facebook or things like that, all of that requires you to go native. One big omission, for example, is WebKit. If you want to display some web content, then you must use a native controller. Qt 5.5 introduced the web view, which is a wrapper, and essentially does what we're going to talk about right now. So in order to integrate the two, you need to use another language. And this language is Objective-C++. So it's a language where Objective-C and C++ can cohabitate in the same source file. So it's a .mm file, and in this case, you can use both C and Objective-C++, and Objective-C in the same source. Really useful, much easier to integrate with the native APIs than it is on Android, for example, where you have to jump through JNI. Here, there's this language where essentially you can use both. And you can access then any native toolkits. So, very quick example of doing that is, said earlier on that the text view doesn't behave very nicely. So one way of doing that is to provide the native text view if you want to do some text input. And one way of doing that is to use to subclass QQuickItem. So here I'm subclassing QQuickItem, and I'm going to render in the area of my QML that this QuickItem inhabitates. I'm going to create a native control and insert it over the QML view at that location. So it is inserted over, you can't draw QML again over that. It is hiding the whole QML scene, and we'll see that we need to, if that area resizes or moves, then the control will need to be resized or moved, and it often lags a bit, so it's not ideal for items that change size or get animated, but it's the easiest way of doing it. So derived from QQuickItem, and the important bits is to handle a window change signal and a visibility change signal and overload a virtual method geometry changed. And then I'm going to build one of these, which is a native UI text view, which I forward declare here using this macro. The reason I need to use this macro because this is the header file, so it's going to be included both in my Objective-C file, Objective-C++, where it's perfectly legal to use things like UI text view, but I'm also going to hash include it in my main.cpp in order to register it to the system. So any syntax in the header file needs to work as a pure C++ file. So that's why that macro was there. So here I register my type. You've probably already done this. Text view, QuickItem, I'm going to listen to these signals. When my item created and gets assigned to a window, I'm going to allocate it. So this line here, for example, that's Objective-C. All the rest before that was C++. You've all done connections and things like that. This line is Objective-C. Same here. I need to insert my item that I've just created as into the native UI window that the QPA creates for you. So that's done by casting the window ID of the window I just received. Set some tech on it and add it as a subview. And then when its geometry changes, I need to change its geometry and move it around. This code here, that's Objective-C++ and structures that UIKit uses. Set it here visible or hidden. Notice common trap, the UIKit you set that an item is hidden, and Qt you set that an item is visible, so you need to inverse the logic, and that's just using properties. So that effectively, if I run it, in the simulator, so that top one here is one of these native controls, the bottom one is a text field. So the native one behaves very much as the native one. You have this this loop that appears. It will do the spelling checking, all of that. And the bottom one here is a native QML one. So that's by far the easiest way with the restrictions that we had in terms of, you're overlaying the QML scene, so you can't draw anything else above it. The other way is to use a QPA, and that's really useful if you're going to completely block your screen to display something maybe like maps or a web view or something like that, and you're going to completely hide your QML with some native controls. On the Qt side, on the QMake side, you need to import this private header to access the QPA. That means that this breaks binary compatibility, doesn't matter, you're statically linked. And then you can poke at the QPA to get the UI view, which is the global view, native view that's used, and then you can just use the regular controls. Yeah, quite easy again, but that's more useful if you're going to completely hide your QML scene. Application delegates. Sometimes you need to be notified of changes state of your application. So application going in the background or coming in the foreground, there's something on Q applications for that, but some things are missing. In particular, because of the memory constraints, sometimes you want to be warned that your application is about to run out of memory. For that, iOS will send your application a notification. The easiest way of getting this is to use what's called Objective-C categories. It's a weird Objective-C construct which basically lets you override or add methods to a class that's already defined, but for which you don't have the code. So QiOS application delegate is the default application delegate that's in a QPA. But you just hear, I pretend I know it by declaring that it exists, and I'm defining this category on it. And when I implement it, I'm just overloading one of the methods. You need to be a little bit careful, because if you're overloading a method that actually Qt uses and relies on it being called, you might break some behavior. In this particular case, application did receive memory warning, signals you that your application is using too much memory, has allocated too much memory too frequently in the last time. So it may be fine, it might not be killed straight away. It's just a warning by the system to tell you, hey, why don't you free up a little bit of resources here. Another one is the handle open URL, which is used if you associate your application to file types. Another way of doing that is by providing entirely your own delegate. I'm not going to go through this example here, but essentially you are replacing the one that Qt inserted there in the first place. It's actually fine because the Qt one doesn't do anything, and the one thing it does you can't break, you can't replace. Very briefly, a couple of slides about using CMake. We've been using QMake up to now. CMake works just fine to build iOS applications. The one thing it doesn't do as well as QMake does is this static linking thing, and automatically generating these two CPP files that have the macros that are used to statically link to the right plugins. QMake does that by looking at which modules you've added to the Qt variables, and it has this script called QML import scanner that will grep through all your QML files and generate a JSON data structure of everything that needs to be imported. So there's no reason why somebody couldn't provide some integration within CMake to do that. The CMake's perfectly capable of running scripts and all of that. It hasn't been done. Hasn't been done yet. All the rest you can specify the way you would normally do with CMake. Automock comes really useful, and at the end what you get is an Xcode project. Yeah, won't go through too many of those details. Because it doesn't know about a lot of the libraries, you need to be a bit more explicit about what you link against. It's a bit painful. A brief word about building libraries. As I said, by default, it will build static libraries. Since iOS 8, it's legal to build shared libraries. In particular, it's illegal to build frameworks, which are bundles of dynamic libraries with their headers. If you just do a shared library, a .dylib on macOS and iOS, it won't work fine if you deploy your app from Creator, but once you get to and run from Xcode, it won't work because Xcode doesn't support, enforces the rules that dylibs are forbidden, that you need to use frameworks. So it will skip your frameworks and your application will fail at startup time. So you need to build bundles, and that's what this lib bundle does to do. It does in QMake. Briefly, application extensions. So that's an application that lives inside your bundle. So it's an application inside your application, and that can be used from within applications. Or for the Apple Watch, for example, you can't use Qt at all for Apple Watch because it doesn't support UIKit. It's really, you can't really do it easily with QMake or CMake because they don't have really support for building an application inside another one. It's fairly trivial to do, but it's just all to do with file name extensions for the bundles. So you need to go pure Xcode, and it would take way too much time. So briefly, a quick demo of a project I put together to highlight some of the things we just talked about. So ruthlessly copied the demo application, or tried to copy. I'm not a designer, so it obviously doesn't look that nice, but this is all QML. List view with a delegate, that all works fine. And then you can switch views using the bottom app. So notice here how it went from one view to another. One of the typical tricks of QML is to load all your user interface at startup time. And it becomes very slow to initialize. In this particular case, I'm dynamically loading up my views one after the other when I switch the tabs. And I'm doing this animation from one to the other. The typical way of loading dynamically QML modules is to use a loader. Now the loader is destructive. It loads and it deletes everything that was there before it and it replaces it. So you can't do this animation from one to the other. So the typical way of doing that, there was a slide earlier on that I skipped, is to use components. So you load your components, you instantiate it. At that point you have your two views that exist, and you see how I have this little animation. I scale out, I slide, and I scale back in. So really easy. So the map module is supported. I have no idea why it always focuses on Manchester. That's probably where KDAB UK is, the headquarters is. I'm sure that's why. Does the whole OpenGL and the particles and things like that just fine. Qt3D also is supported, so it's a very, very simple 3D scene that you see. And just maybe if I have a couple minutes, yeah, I have a couple minutes, just to show you quickly one feature at the top. You'll notice here that the content of my window goes underneath the status bar. So it's full screen underneath it. Which is a nice thing that was introduced for iOS. Obviously, you need to think about it when you put components, because you don't want to put anything that you need to click on underneath there. Another thing you need to think about is color. So you notice here, I'm changing its color. So the way to do that is to, again, you need to fall back to native, and when you switch views, you need to tell it to change colors. I think that example and all that code is not available in the slides, but if you come and talk to me, I can share that code and make it available for all of these examples. And that's it. Thank you. Questions?
Have you got any ETA, or is there any plans at all to make Qt applications look like native iOS?
No, I don't know. You need to talk to the Qt company for that. I think, yeah, contributions are welcome as always, but yeah, it's a lot of work. One of the things that was on the other side is, define native, because it changes a lot, yeah. And you'll probably want to customize your appearance anyway. So, yeah.
Are there any plans to support Swift instead of Objective-C?
Well, Swift will talk to Objective-C, and that's the only way you can interface with anything else. So currently it is possible, but you need to have an Objective-C layer to forward the calls to C++. There's no direct link from Swift to C++. Sorry? Yeah, the slides will be available, yeah. No, but I can, again, if you give me your business card, I can send it to you. Yeah.
Accessibility. Can a blind person use a QML?
To be honest, I'm not sure about what the support, because QML does support some accessibility API, but I'm not sure how that's been exposed to QML. It probably not would be my guess, but I'm not sure.
Send me all the examples.
Sure, I'll do that.
Thank you very much.
Right.